In this Research Methods Basics video, we're going to be talking about confidence intervals. As a social scientist, you're going to want to know how well, this is what we want to know, how well does our sample represent the population that we're interested in. In criminology and criminal justice, because we're often interested in the behavior of groups or individuals, we want to know, and we're not going to be able to, we're not reasonably going to be able to collect data on all people in the world or all individuals in a given city or state. We can probably come close with smaller cities and smaller counties, but that's very expensive, very time consuming. And so if we want our research to be meaningful and still be generalizable, right? That's another way of asking this question. Can the findings from our sample be applied to the population? Is our sample good enough that whatever we find is representative of the entire population? We're going to have to learn more about confidence intervals with a really descriptive kind of research question. And we're going to imagine ourselves working for a city's violence intervention program. And in a violence intervention program, often folks who are participants, those who are recruited to be a part of the violence intervention program, are folks who are at very high risk for committing gun violence, particularly. And one way that violence intervention programs kind of intervene in gun violence is they ensure that people at the highest risk for either perpetrating gun violence or becoming the victim of gun violence receive different social services. Maybe they need substance abuse treatment, or they need help with education, or they need help finding a job. Or maybe they just need help with basics for everyday living, right? They need some assistance with childcare, or they need assistance with goods like diapers and formula or food. So VIPs, violence intervention programs, often connect folks at risk for gun violence with social services to help address the underlying causes for the violent behavior. So I want to know how many of my participants in a violence intervention program complete different social service programs. So luckily, an intern for the data analyst has been keeping track of the average number of VIP participants who complete social services every month. Our intern has provided us with 3 rows of data, but that's all we have. Now, let's say these 3 rows of data actually represent 1 month for every year. That's great. something. But how do we know if this sample is representative of all of the VIP participants? We asked our intern how they got this sample, and they told us that they randomly assigned the thousands of VIP participants a random number, and then every month they selected randomly so that everyone had the same chance of being chosen for the sample. They randomly selected folks by their random number and recorded whether or not they had completed whatever social service program they'd been assigned to that month. So we know we have a random sample. And the intern has been collecting these data randomly for roughly 3 years, every month. So 3 years every month, we could do one of two things. I'm going to use a little n because this is a sample, not a full population. We could count each of these numbers, or we could say there's 12 months in a year, 3 years. This actually looks like more than 3 years worth of data. It's 4 years worth of data. So actually, our intern collected it like this. Okay. Okay, we have 4 years worth of data, 12 months out of the year, so 12 times 4. So we have 48 months where we have the average number of VIP participants who completed a social service program. To describe this sample, so let's start with some basics. We know that the sample is 48. Now, what is our sample mean? To get the mean, we are going to take the sum of all x's, divide it by the size of our sample. So if we add up all of these numbers, I did to pause here, give yourself a moment to sum all of these x's. We can just work it together. Added all of the x's, you'll probably come up with 458. That's what I came up with. So x bar, or our sample mean, is 458. Oops. Divided by 48. And once I complete that math, I come up with a sample mean of 9.5 folks who complete a social service per month while they're participating in our VIP. Do we know? Does that represent all of the thousands of VIP participants in our program? Well, let's try to figure that out. I want to be able to tell our stakeholders how confident I am that this sample average number of participants are completing social service programs every month. I know my sample is random. I know that my sample size is 48. And now I can do a couple of things. I can either work out the sample standard deviation, or I can rely on what I know about the central limit theorem, and I can use the sample standard deviation to represent a population standard deviation. And then I can use the Z critical values to create a confidence interval. Why can I use Z critical values? Well, because I know that I have a random sample and my sample is fairly large. Remember, you can use Z critical values just so long as your sample size is greater than or equal to 30. So, when we're working with confidence intervals, X bar is also referred to as our point estimate. Okay, so the next step, we've already, because we've calculated our sample mean, we've already developed a point estimate. So for these sample data, our point estimate is 9.5. Now, it'd be nice to have a range of values that I could give to our stakeholders to say something like, on average, this many VIP participants between, I'm going to guess here, between 4 and 11 complete a social service program per month. In order to say something like that, I need to create an interval estimate. That's what we'll do in the next video. Here are the steps that we're going to take. We are going to calculate S, which is the sample standard deviation. Then we'll determine our margin of error. And finally, we'll use a Z critical value because our sample size is greater than 30, so we know it'll fit in a normal standard distribution. We'll use a Z critical value to conclude our level of confidence that our sample mean or our interval estimate truly represents the population.